how can nuclear fusion and nuclear fission both produce energy when they're opposite reactions? Well, that's a great question. First, here's a little clue. The fusion of small atoms and the fission of large atoms both increase the stability of the atoms involved. Okay, so the key is called the atomic mass defect, which goes like this. Protons, neutrons, and electrons each have a specific mass. So when you combine a certain number of them to form an atom, you'd expect the mass of the atom to be the sum of the masses of all the particles in that atom. But in fact, the atomic mass is slightly less than that sum. This is because the atom is more stable than the individual particles, meaning it requires less energy to exist than those particles. The difference in energy is called nuclear binding energy, and it is the amount of energy necessary to split an atom's nucleus. As atomic mass increases, the binding energy, Be, also increases because the atom becomes more and more stable, meaning it requires less and less energy. Therefore, when you fuse two small nuclei, the new, larger nucleus requires less energy than both of the small ones, and the excess is released. Now, you might be thinking, if fusion produces energy, shouldn't fission only consume energy? Well, not exactly. See, Be only increases to a certain extent. Iron 56 is the most stable element and has the maximum Be. Elements larger than iron begin to decrease in Be because the strong force, which holds the nucleus together, has less of a pull on the particles near the edge of the nucleus, making it unstable. Therefore, when you fission a heavy, unstable element into lighter, more stable ones, the binding energy is increased and energy is released. Thus, both reactions produce energy because they both increase the stability and therefore the binding energy of the atoms involved.